All right, ladies and gentlemen, today we're going to switch gears from graphing for a little bit and talk about how rational exponents are related to radicals and roots. So before we get on, a couple of things about what a rational exponent is. So when I say rational exponent, a rational exponent is basically when you have an exponent that's a fraction. So this 1/2 here would be a rational exponent. Okay, it's an exponent that is in fraction form. Okay, so once we got that out of the way, it's a very simple rule that we have to remember. What you have to understand is when you have a fraction that's in the exponent, we actually can convert it into a radical format. Okay, and I'll show you how to do it. It's very simple. There's two different ways to write it. I will show you that as well. But the gist of it is fractional exponents or rational exponents can be turned into radical expressions. That's what we call a radical expression here. Okay, and vice versa. If you have a radical expression, we can turn it back into a rational exponent. We'll do an example here. There's some vocabulary words you got to become familiar with, but just understand we can convert a problem that looks like this and turn it into a root problem. Or we could take a root problem or radical problem and turn it into an exponent problem. So let's look at this example here. We got 27 raised to the 2/3 power. So let me write that just a little bit nicer. So it's 27 to the 2/3 power. Okay? This number here, we call this guy in exponent form, we call the base. So just get comfortable with that vocabulary word. The base is the number or variable that is being raised to the power. Okay? This guy here is the exponent. In this case, it's a rational exponent because it's a fraction. So how do we convert? Pretty simple. We're going to take the base, and the base is the guy that's going to go into the radical. So the base goes into the radical, okay? The exponent goes into two different spots. The bottom number will be your index number, okay? So this is your root. So the bottom number turns into the root. This is your root, and that number will go here. Your top number is your power. And your power can go in two spots. Right now, I'm going to put it inside the radical with your base. Okay? If we had to do this slightly different, this is another way we can do it. We do a radical, a base goes in the radical, our root stays on the outside, it's our index number, okay? And now we would go ahead and put our power, in this case the number 2, outside the square root. These two radical expressions are equivalent. They mean the same exact thing. Okay? So that's how we basically convert a rational exponent, an exponent that's a fraction, and we convert it into a radical expression. So again, these here are considered radical expressions. Okay, so to sum it up, rational exponents or fractions that are in the exponent spot can turn into radical expressions. The top number of the fraction is your power. The bottom number of your fraction becomes your root, and this is how you convert it. Okay? We're going to do more examples, and we're going to actually do the math for the following examples. All right, guys, let's do this first example. So we have 4 to the power of 3 over 2. Again, I like to rewrite it. I don't like those horizontal fractions, so it's really 4 to the 3 over 2 power. And to solve this, to make this a little more easier to comprehend, I'm going to convert it. So my base, which is 4, is going to go in the radical. The bottom number, which is my root, becomes my index, which is the number that goes outside the root. And the power of 3, you can either put it inside the root or we can put it outside the root. Okay? I'm going to just put it on the outside for now. So what we're going to do is actually do this math. The first thing we're going to do, what I like to do, is always take the root first. So in other words, we're going to take the number 4 and we're going to root it by 2, or what's the square root of 4? So when we do that, the square root of 4 is 2. So again, we took care of this math part. We do no longer need the radical symbol because we used it here. Now we take our answer from that and we're going to raise our answer to the power of 3. So now we can bring the 3 in. And all we got to do now is understand what is 2 to the third. Or in other words, we're doing 2 times 2 times 2. And that's going to give me 8. And that would be our final answer. All right, let's jump here to example D. So if you look at example D, if we try to do this math the way it's laid out, we would have to take the root, the third root or the cube root of 11, and then whatever answer we get, we raise it to the power of 6. Okay? Well, knowing just a little bit of math, the cube root of 11 is going to give us a nasty number, and we're going to have to raise that nasty number to the power of 6, which is not usually a good thing to do. What we can do is convert this into a rational exponent, or reverse it into the base raised to an exponent. So we're going to reverse this and you're going to see what happens. So if you recall, we're going to write down our base, and this is going to now turn into a rational exponent, or a fraction in the exponent spot. Remember, the root number or the index number, this is the number that goes on the bottom. So the 3 goes on the bottom. The power number, whether it's inside the radical or outside the radical, the power number goes on the top. So if you look at this problem now, and you know a little bit about fractions, I actually can reduce this fraction. I can go 6 divided by 3, or reduce it, and I end up with 11. And if I reduce by 3, I get 2 over 1. So again, I am reducing or dividing the top by 3 and the bottom by 3, and it reduces to 2 over 1, which 2 over 1 is just really 2. So now I can actually do this a little simpler, because I now know 11 to the second power is equal to 121. And we don't have to mess with nasty radicals or crazy exponents. We could turn it into fraction, see if the fraction reduces, and it turns into a much simpler exponent.